You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we will define and explain one of the most critical concepts in computing, the operating system. Often referred to by its abbreviation OS, the operating system is the foundation upon which every computing experience is built. From the time you power on a device to the moment you shut it down, the operating system is working in the background to manage hardware, run software, and support your interactions. Understanding the operating system's purpose and structure is essential for the IT Fundamentals Plus exam, especially as it relates to system components, resource management, and user access. This topic appears in Domain 3 of the IT Fundamentals Plus certification. You will not be asked to configure or troubleshoot an operating system on the exam, but you will need to understand its general functions and core components. The questions may ask about how the operating system interacts with files, hardware, or applications. You will also be expected to recognize different types of operating systems, such as those used on mobile devices versus desktop computers. Mastering this content will help you develop a strong foundation in both computer literacy and future technical studies. An operating system is a type of software designed to control and coordinate the use of a computer's hardware and software resources. It acts as an intermediary between the user and the physical components of the system. Without an operating system, a computer would be unable to perform basic tasks like displaying information on a screen, responding to keyboard input, or running programs. The operating system is essential to the functionality of any computing device, from personal desktops to large-scale servers. There are several types of operating systems designed for different platforms and devices. Common desktop and laptop operating systems include Microsoft Windows, Apple Mac OS, and various distributions of Linux. On mobile devices, the most recognized systems are Android and iOS. Beyond consumer devices, specialized operating systems exist for servers, embedded systems, and industrial machines. These tailored systems are optimized for specific tasks, such as high reliability, minimal resource usage, or real-time control in manufacturing environments. The core responsibilities of an operating system can be grouped into three main areas. First, it manages hardware components like the central processing unit, memory, and storage devices. Second, it provides a user interface, which may be graphical or command line based, to allow users to interact with the system. Third, it coordinates the execution of software applications by allocating system resources, scheduling processes, and ensuring that multiple programs can run simultaneously without conflict. One of the ways the operating system communicates with hardware is through the use of drivers. A driver is a small piece of software that acts as a translator between the operating system and a specific piece of hardware, such as a printer, graphics card, or external drive. These drivers tell the operating system how to send and receive data to and from the hardware. In most modern systems, drivers are installed automatically when new hardware is detected and may be updated periodically to improve compatibility or performance. File management is another key function of the operating system. It organizes data on storage devices using a file and folder system. This includes tracking where each file is stored, maintaining attributes like file size and creation date, and allowing users to name, search for, move, or delete files. The operating system also handles file permissions, determining who can read, write, or execute each file. These management capabilities ensure data is organized, protected, and easily accessible. Memory and resource management are vital for system stability. The operating system allocates memory, or random access memory, to different applications and processes. It decides which program gets access to which portion of memory and for how long. The operating system also manages processor time, switching rapidly between tasks to create the illusion of simultaneous execution. This prevents one program from consuming all the resources and ensures that multiple tasks can be completed efficiently and reliably. User and access management is an important feature in operating systems that support multiple users. The system allows individuals to create user accounts, set passwords, and manage personal settings. It also enforces permissions that control which files or system settings each user can access. In multi-user environments such as schools, offices, or shared computers, this ensures that users' data remains private and that system integrity is preserved. These access controls form a basic layer of security and accountability. The startup process of a computer is also coordinated by the operating system. When a device is powered on, the system firmware performs basic hardware checks and then passes control to the bootloader. The bootloader is a small program responsible for loading the operating system kernel into memory. Once the kernel is active, the system initializes background services and loads the graphical or command line user interface. This process ensures the device is ready for use and able to respond to user inputs. Providing a user interface is one of the most visible functions of the operating system. Most modern systems use a graphical user interface, or GUI, which includes windows, icons, menus, and pointers. This allows users to interact with the system through visual elements. Some operating systems also support command line interfaces, which require users to type text commands to perform tasks. Both interface types allow users to launch applications, change settings, and manage files, though the graphical version is more common among everyday users. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The operating system plays a central role in supporting applications. It provides the necessary environment for software to be installed, launched, and managed. This includes offering system calls, application programming interfaces, and runtime libraries that allow software to interact with the system hardware. In addition, the operating system ensures compatibility between different applications and manages how each program accesses memory, files, and processing time. Without this coordination, software would not function reliably or efficiently. In the background, the operating system also runs various system services and processes that are essential to daily operation. These services handle tasks such as maintaining network connectivity, sending documents to printers, managing system time, and updating internal databases. Many of these processes start automatically when the system boots and continue to run without user interaction. Although they are not always visible, they form the backbone of system functionality and keep the operating environment stable and responsive. Security is another important area managed by the operating system. It includes features such as login credentials, file permission systems, and administrative controls that determine who can access specific system resources. Many operating systems also include built-in security tools like firewalls, antivirus scanners, and encryption support. These tools help protect against unauthorized access and malware, especially in multi-user environments or systems connected to the Internet. Regular updates help address new vulnerabilities and improve system defenses over time. Device management is a key function that allows users and administrators to monitor and control connected hardware. The operating system maintains a list of all connected devices, such as printers, webcams, keyboards, and external drives. It also provides tools to enable or disable these devices, check their status, and resolve any issues. For example, utilities like Device Manager in Windows or equivalent tools in other systems allow users to see driver details, reinstall malfunctioning components, or configure hardware-specific settings. Updates and system maintenance are vital to keeping the operating system secure, efficient, and compatible with new hardware and software. Most modern operating systems include tools that automatically check for updates and apply them as needed. These updates may include performance improvements, new features, bug fixes, or security patches. Some updates require a system restart, while others can be installed in the background. managing updates properly helps ensure the system remains reliable and up-to-date. The operating system also includes built-in tools for task scheduling and automation. This allows the system to perform routine tasks without manual intervention. For instance, you can schedule automatic backups, virus scans, or software updates to occur at specific times. These tasks are usually configured through graphical interfaces or administrative utilities and help maintain the health and efficiency of the computer. Automation reduces the burden on users and ensures important maintenance activities are completed consistently. It is important to understand the difference between user-level and system-level functions within an operating system. User-level functions include actions like launching applications, browsing folders, or adjusting volume settings. These are tasks that require no special permissions and are typically available to all users. System-level functions, on the other hand, involve managing system settings, controlling services, or installing updates. These tasks may require administrative access or elevated privileges. Understanding this distinction helps users navigate the system responsibly and securely. Operating systems also support networking capabilities, enabling devices to connect to the Internet or local area networks. The OS provides configuration tools for Wi-Fi, Ethernet, or virtual private network connections. It also manages settings like IP addresses, subnet masks, and gateway information. Beyond connectivity, the operating system can enable file sharing, printer sharing, and network discovery so that devices on the same network can communicate efficiently. This functionality is essential for collaborative environments and Internet-enabled applications. When preparing for the IT Fundamentals Plus exam, expect to see questions that test your understanding of how the operating system manages devices, users, files, and applications. You may be asked to identify which component of the system handles a specific task, such as managing memory or supporting security. Other questions might ask you to match operating system types to appropriate usage scenarios, such as identifying which systems are best suited for mobile devices versus desktops. Focus on roles and definitions rather than configuration steps. To conclude this episode, remember that the operating system is the foundation that allows all hardware, software, users, and data to work together. It controls how resources are allocated, how users interact with the system, and how tasks are scheduled and completed. Whether you are launching an application, managing a file, connecting to the Internet, or securing a device, the operating system is playing a silent but vital role. A clear understanding of these functions is necessary for success on the IT Fundamentals Plus exam and will prepare you for deeper exploration in future IT studies. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.